So welcome to your video notes 5.2, the indefinite integral. So a function, so far we have practiced taking the derivative of given functions. So now we're going to do the opposite operation, which is finding the antiderivative of a function. So integration is how we find the antiderivative. So if we know the derivative of f of x is f prime of x, then the integral of f prime of x dx equals f of x. So the integral of the derivative is the antiderivative. So let's apply that here below. So the derivative of x cubed is 3x squared. So its equivalent integral tells me that the integral of 3x squared dx is going to equal x cubed plus c. Because remember that if we had 3x squared plus 0, a constant differentiates to be 0. Next up, we have the derivative of square root x is 1 over 2 square root x. So the integral of 1 over 2 square root x dx equals square root x plus c, keeping in mind that that c differentiated to be 0. Next, the derivative of tan t is secant squared t, so the integral of tan t dt, did that backwards. The integral of secant squared t dt is tangent t plus c. And then last but not least, if this derivative is true, then the antiderivative in terms of u is equal to u to the 3 over 2 plus c. So keep in mind, whenever we are finding the antiderivative, we're working backwards from a given derivative, and we always add that constant on the end because the derivative of a constant could have been here to be 0. So now a couple of rules, more than a couple, that we need to be familiar with connect directly to the derivatives that we have practiced before. So the derivative of x is 1. So the antiderivative of dx is x plus c. One that I want to point out that comes up quite a bit is this one. The antiderivative of r to some power, or x to some power r. Remember, normally when we took the derivative, we would multiply by that power and then divide. We would multiply by that power and then subtract 1. So here we're going to add 1 and then divide by that power to work backwards. That's used quite a bit. The rest of these are just opposites that we will memorize. Another common one that people sometimes confuse with x to the r is 1 over x. So keep this in mind that all of these derivatives we should have memorized, which helps us to memorize all of these integral formulas or antiderivatives. So let's get into some practice problems.